Hey guys, Mr. Milton here. Today we're going to talk about proving lines parallel. Okay? At the end of this video, you should be able to differentiate or tell the difference between the theorems from last lesson and their converses in this lesson. You should also be able to prove that lines are parallel. Okay, so tool that you'll need today is you'll need to be able to talk about converses. And so let's recall that from last unit. Write the converse of the conditional. If Jack gets an A, then he gets a 98% or above. Remember that converse meant that we flipped the hypothesis and conclusion. And so if we wanted to write the converse of this statement, we'd say, if Jack gets a 98% or above, gets a 98% or above, then Jack gets an A, and then he gets an A plus. Okay, and so just flipping the hypothesis and conclusion, remember that if and then stay. They are not a part of the hypothesis or the conclusion. Okay, now last lesson we learned three properties of parallel lines that are cut by transversal. Today we're going to look at their converses. And so let's go through and just write those out. Corresponding angles postulate says if two lines are parallel, then corresponding angles are congruent. The converse says that if corresponding angles, and I'm going to abbreviate, are congruent, then two lines are parallel. Okay, in this diagram, what's given to us? What do they tell us? Well, they tell us that by these arcs here, that angle 1 is congruent to angle 2. Okay, those are corresponding angles. And so since corresponding angles are congruent, we know that these two lines, the lines that the transversal intersects, L and M, must be parallel. So from knowing that these angles are congruent, we can tell that the lines are parallel. Just proves it. Alright, alternate interior angles theorem says if two lines are parallel, then the alternate interior angles are congruent. So its converse would say, if the alternate interior angles are congruent, alternate interior angles are congruent, then two lines are parallel. Same with the same side interior angle. If two lines are parallel, then the same side interior angles are supplementary. We can write a converse for that. If the same side interior angles are standing for supplementary, then two lines are parallel. Okay, and I hope you get the gist of this. They're basically just approaching it from the other end. Okay, notice that yesterday that lines were parallel and we proved something about the angles. Today we're given something about the angles and we concluded that the lines are parallel. Okay, you need to make sure that you can tell the difference between the two. Know when you're starting with the angles or know when you're starting with the lines. Okay, when you're given that the lines are parallel, those would be the theorems. When you're given that the angles are congruent first, those are the converses. Okay, alright, let's go through some examples on the back here. Okay, which lines, if any, must be parallel for angle 1 to be congruent to angle 2? Justify your answer with a theorem or a postulate. Okay, so I like to mark these things. 1, 2. Alright, and here's my hint. Those angles both have to touch the transversal. Okay, they both touch DK. That's the transversal here. Okay, and now the other lines that make this up are going to be the lines that have to be parallel. So what other lines make this up? Well, DE and CK. Okay, so they both touch this line. I know it's the transversal. Now I'm looking at the other lines that create the intersection, and that's DE for angle 1 and CK for angle 2. Okay, and they have to be parallel because of the converse of the alternate interior angles postulate. Converse of alt int angles. Okay. Next one, which lines, if any, must be parallel if angle 3 is congruent to angle 4? So I'm going to mark this again, angle 3, angle 4. Well, I see that those are corresponding angles. Okay, and they both touch CK. Okay, and so what other lines, what does CK run into? Well, CK runs into EC and DK. Okay, which lines, if any, must be parallel if angle 2 is congruent to angle 4? Or sorry, if angle 2 plus angle 4 equals 180. Well, 2 is right here, this blue. 4 is right here in the blue. Does anything have to be parallel for those two? No, they create a line. They're supplementary. So no lines. Okay, they could still be parallel, but those two angles will always equal 180. They'll always be supplementary because they're a linear pair. They make up a straight line. All right, which lines, if any, must be parallel if angle 1 is plus angle 4 is 180? Okay, so angle 1 here, angle 4 here. Well, I see that they're both touching DK. Okay, so that's the transversal. And so the other two lines that intersect with that transversal, DE and CK, these two are same side interior angles. Okay, so I'm going to say that DE, again, and CK. Okay, those are same side. It's actually the converse of same side interior angles. I didn't do that with 3 and 4. 3 and 4 would be the converse of corresponding angles. Okay, and so that's just us looking at these lines, trying to find, or these angles, finding out what types of angles they are, and then seeing if that relationship matches up with what we know about parallel lines. If it doesn't, we say they don't have to be. And if it does, then we find out and we use the converse of the postulate. Okay, a couple examples here. So this says find the value of x that would make L parallel to M. Okay, and so what we're going to do here is we're going to use our information that we know. So if L is parallel to M, there's a few things I know. I know that the corresponding angles have to be congruent and that alternate interior angles would have to be congruent. Okay, now right here I'm going to start with corresponding angles because that's what I kind of see is going to happen. This is kind of tricky because they don't start off by giving us corresponding angles. They give us these two angles out here. But I'm going to use what I know about vertical angles to say, well, if this is 2x plus 26, this has to be 2x plus 26 as well. And now I can say, well, 3x minus 33, these two are corresponding angles and L is parallel to M, has to be equal to 2x plus 26. Okay, so now I solve it. X equals 59. And I use the converse of, actually I just use corresponding angles postulate. But first I use vertical angles, so I guess I should talk about that. I use vertical angles first and then the corresponding angles postulate. Alright, let's call some lines L and M. I'm going to call this L. I'm going to call this M, maybe. Let me call this L. Those two look like they might be parallel. I know that one's not. Alright, so if L is parallel to M, what kind of angles would these be? Well, here's the transversal. They are inside our two lines, and they are on the same side of the transversal. So I know they'd have to be same side interior angles. Okay, and so same side interior angles are going to add up to 180 degrees. So I'm going to say 3x minus 4 plus 5x plus 16 should be supplementary, add up to 180. 8x plus 12 equals 180. 8x will equal 192, and then x will equal 24. And so x would have to be 24 for these lines to be parallel, and I know that because their same side interior angles would be supplementary. Okay. Alright, so using corresponding angles, vertical angles, same side interior angles, alternate interior angles, we can use their converses, and now we can prove that lines are parallel because of what we know about their angle measures. Alright guys, see ya.